Okay, so we're gonna do this last practice one, and then that'll be it for the day for me telling you what's going on, and then the rest I'll have you work on some practice problems. But so in this case, we're saying a circular loop is placed near a long, straight, current-carrying wire in which the current is either increasing or decreasing. In which of the following situations is the induced current in the loop counterclockwise? So this is kind of a tricky situation. I'm gonna switch over to this and just pull up my surface so we can look at what is going on. So I like to always kind of draw a picture when I'm approaching this. I'm gonna move this, sorry if the audio gets a little bit weird. So in this case, I think we should best go about this by going one by one and thinking about what we're looking at. So we want to know in which of the situations is the induced current in the loop counterclockwise. So what I'm going to do is just kind of draw in, choose one, and say counterclockwise as if we are going in this direction. And if we are going in this counterclockwise direction, I'm going to use my second right-hand rule. My thumb is in the direction of the current. And I see in this case, within the loop of wire, I will always have, I'm going to get a smaller pen, current that is out of the page based on my second right-hand rule. So what I'm going to look at is, or not current, sorry, magnetic field that is out of the page. So what I'm really looking for is I'm looking for a situation where my magnetic field is getting less out of the page. So we're looking for something that is getting less out of the page for my magnetic field, because we know that this current is going to be induced in such a way to oppose that natural change. So if we want a counterclockwise current, it is going to be producing a magnetic field that is out of the page. So it's going to be producing that to compensate for the decreasing out of the pageness of the magnetic field. So if we have a current in this first case, in case A, that is increasing to the top of it where we have this loop of wire, if it is increasing, that means that our B field, sorry if we do our right-hand rule, our B field is increasing everywhere above this wire. So it is not getting less, it's actually getting more. So that one is no good. Let's go down to letter B. In B, let's look again. We want, again, a situation where the current is becoming less out of, or the B field, sorry, the magnetic field is becoming less out of the page. In this case, it's really the same as part A, just flipped. The magnetic field created on the left side of this wire, the side that the loop is on, is out of the page. And if our current is increasing, that means that our magnetic field is also increasing. If we're looking at letter C, in this case, if we are looking below us using our second right-hand rule, below us, our magnetic field is out of the page, and then our current is decreasing, which means that our magnetic field is decreasing. So if our magnetic field is decreasing, if it's getting less, then that means that the current is going to be created to oppose that change. So it's going to go in this counterclockwise direction and induce an out of the page. Oh, whoa. Let's make that smaller. It's going to induce this out of the page current or magnetic field to compensate for the decreasing magnetic field. So it looks like C is our go-to. So now you guys will have the opportunity to practice that. And yeah, I'll make some keys, but I'm not going to give you too many questions because these get really, really similar really quickly. But yeah, so hopefully that wasn't too bad. All right, I will see ya.